I'm here to talk about domain-specific small vision models and to demonstrate why you might choose this approach for your next computer vision project. As Randall mentioned, I'm a computer vision consultant. I work with a variety of startups, particularly in the medical and sustainability areas, and help them reduce the trial and error of model development. This talk is based on challenges I've seen with these organizations and trends in the research literature that can provide a solution. So by now, I believe you're all familiar with foundation models, especially after the exciting keynote talk this morning. And many of you have probably also played with ChatGPT and similar models over the past year or two. These are examples of large language models and also examples of foundation models. This large language model approach has become state-of-the-art for language processing over the past couple of years. Best practices for computer vision are still evolving, but look to be following a similar trend. So in this domain, you might have heard of models like Dino or Clip or SAM, and we heard some of those this morning in Professor Lee's talk. Foundation models are built on the concepts of generality and adaptability. They are trained on broad data sets and can be fine-tuned for a variety of applications and downstream tasks. These downstream tasks can be anything that you might train a deep learning model for. So in computer vision, they typically fall into the categories of classification, regression, segmentation, and object detection. Foundation models can form the foundation of your computer vision capabilities. And while this approach has worked exceptionally well for language modeling, in computer vision, we have a few different challenges that we need to consider and perhaps tune our approach just a little bit differently. The first challenge is that within the domain of imaging, we have many different types of images. So many of the broad foundation models for computer vision are trained on data sets like ImageNet or larger variants of them. These are photos of people, places, and things, images collected off the internet. But there are a number of other specialty imaging domains. Histopathology, which a pathologist might look through the microscope to diagnose cancer. Fluorescence microscopy to study cells. Multispectral satellite imagery to study changes in the earth. Drone imagery to study trees. These are just a few examples. There are many different domains that you might be applying computer vision to, and that within each domain, the textures and the shapes present are quite different. And they're very different than data sets like ImageNet of people, places, and things. And so broad foundation models that are trained on ImageNet type data sets don't necessarily transfer well to some of these unique imaging domains, especially when the properties of these images that you're looking for are fine-grained things.